Okay, now we're going to look at finding the Maclaurin series for the function 1 plus x to the k, where we're going to be thinking about k as any real number. All right, so the formula that we're going to be filling into is that the Taylor series is the nth derivative of f evaluated at the center, which in this case is 0, over n factorial times x to the n. Okay. So our function is 1 plus x to the k. The derivative is k times 1 plus x to the k minus 1. The derivative of that is k times k minus 1 times 1 plus x to the k minus 2, and so on. So the nth derivative is k times k minus 1 all the way down to k minus n. I want this to match up, so here when I took the second derivative I took k minus 1. When I take the nth derivative I'm going to do k minus n minus 1. So that's k times k minus 1 times k plus 1 minus n times 1 plus x to the k minus n. When we evaluate this at 0, we get, well, f of 0 is 1. The derivative of f at 0 is k. The second derivative at 0 is k times k minus 1, and so on. The nth derivative at 0 is just these coefficients, k times k minus 1, all the way down to k minus n minus 1. So k plus 1 minus n. And so our series has this form, the sum from 0 to infinity, k times k minus 1, dot dot dot, to k plus 1 minus n over n factorial times x to the n. All right, we're going to use this formula with k equals to 1/3 to just examine what this looks like. All right, so we found this general form for the terms of the series, but I wanted to say again what this numerator means. So the numerator, to get the numerator, we start at k and we multiply together the first n terms counting down by 1. From k. So for n equals 0, we have 0 terms, so this is actually going to start at 1. So we have 1 over 1 factorial times x to the 0, 0 factorial times x to the 0. For n equals 1, we start at k, so we just have this one term, 1/3. This is divided by 1 factorial times x to the 1. For n equals 2, we start at 1/3 and we count down to negative 2/3. We're multiplying these two terms together and divide by 2 factorial times x squared. Then we go to n equals 3, so we start at 1/3, we count down until we have 3 terms written down. So we have 1/3, negative 2/3, negative 5/3 over 3 factorial times x cubed. And finally, at n equals 4, we're going to multiply together 4 terms. So we have 1/3, negative 2/3, negative 5/3, and negative 8/3 over 4 factorial times x to the 4th. And so here are our first 5 terms of the Maclaurin series.